Hans Müller.
Okay. All right, so let's start. Hello, welcome. Thank you for attending this webinar on myotonic dystrophy. The title is Addressing Disease Heterogeneity in Myotonic Dystrophy Towards Personalized Intervention. The seminar will focus on the development of individualized interventions in myotonic dystrophy that take into account the clinical heterogeneity between patients that meet personalized treatment goals. The topic will be addressed from the patient perspective, and Alain J, President of Euro-NMD, will interview a patient participant, Pierre Gibson. And from the perspective of a clinician and clinical researcher, I'm referring to Professor Basil van Engelen from Neurology Department, Radboud University Hospital, and a basic researcher also from Radboud University, Professor Peter Brown, who is a professor in bioinformatics. So without further ado, I thank everybody for your cooperation and presence, and I would like to give the floor to yourselves. Pierre, please, and Alain, go ahead.
Thank you so much, Antonio. My name is Alain J. I am 64 old, retired engineer, and my family is affected by myotonic dystrophy type 1. The adventure of Euro-NMD started late 2019, looking at the DM community of scientists, clinicians, and patients. I had noticed before that the patient voice was a little bit uncoordinated in Europe and more or less difficult to hear. So I decided to found Euro-NMD. Euro-NMD is a patient organization fully dedicated to myotonic dystrophy in Europe. Our members are nationwide neuromuscular patient organizations from 10 countries at the time, either fully committed to this disease or non-dedicated ones, but including a DM support group. In France, I am driving such group at AFM Teleton, which allows me to maintain contacts with hundreds of patients. I have noticed plenty of similitude between all of them: heart issues, fatigue, gastrointestinal, myotonia, but also plenty of various situations and symptoms, more or less adapted to standardized protocol, especially, for example, cognition. Pierre Petit, DM1 patient from Belgium and member of Euro-NMD, is joining us today for this meeting. Hello, Pierre. Could you introduce yourself, please?
Okay. Hello, everyone. Excuse me for my speech disorder. I'm 58 years old, in early retirement since 2.5 years. I hold an MA in economics, and I'm a former executive in a utility company. I have a DM1 with adult onset, caused by twice as many repeats as my late asymptomatic father. I am married. I have 4 grown-up children in their 30s, 2 of them with juvenile onset of DM1. And they have approximately 5 times as many repeats as myself. And I'm also the proud grandfather of already 4 quite healthy grandchildren.
What is the most frustrating symptom in your day life?
Well, I don't really have a single most frustrating symptom. I'm going to talk about my top 3 annoying symptoms, which are, first of all, and without a doubt, excessive daytime sleepiness. The second one is quick fatigue after physical activity. And the third one is muscle weakness. What until recently I was talking about muscle weakness about everywhere in the body, but it's become more and more muscle shear loss. But for the rest, I experience mostly all the other symptoms which I can find in the literature, but to a lesser extent.
What about the other people affected in the disease in your family?
Right, apart of course, first of all, my two sons with severe learning problems since they are in kindergarten. They have slurred speech and lots of intestinal disorders. One of them has a pacemaker, he wears a mask at night, and he suffers from regular intestine subocclusion, almost once a year. I'm also an older brother, and two of his 5 children were affected, but to a lesser extent. And then, sadly enough, my older sister died suddenly in 2019, and she was barely 64. And 3 of her 4 children are also affected by DM1. And there are also 7 children of my cousins, and one of them was affected from congenital form. And for our family, was a real starting point for the awareness of the whole family. Because at that time, the DM1 diagnosis hadn't yet been made for my children. We didn't know about DM1.
Did you notice any heterogeneity of symptoms in your family?
Not really. I would rather talk of heterogeneity in the extent to which each member is affected for each symptom. And my personal conviction is that more or less, we will all, sooner or later, have to cope with our symptoms.
And how do you face this variability?
With much philosophy, Alain. My recipe is to take one day at a time and not spoil my present life with grim thoughts about the future.
What are the expectations or wishes to handle more efficiently the effect of the disease?
Well, I intend to continue like we do, that is at least attend once a year multidisciplinary follow-up provided by the Neuromuscular Center at the University Hospital in Brussels. And also maintain weekly visits to the physiotherapist and to the logopedics. But above all, I want to give as much care and love as possible to my children, who fortunately feel good in their own bubble, and then they don't project themselves towards the future. And then finally, my personal expectation is that a repairing cure may finally be found, probably not in my lifetime, nor in their lifetime. And of course, I hope I will be proven wrong.
In your country, I assume that care programs are compliant with standard protocols. Is it acceptable for you, or would you prefer more personalized interventions?
Well, frankly, these care programs that are for me quite acceptable. I'm totally satisfied with care programs provided by the Neuromuscular Center at the University Hospital, and I regard them as genuine personalized intervention. But at this stage, for my case, I personally do not feel the need for more personal intervention. However, I can fully imagine that this is not enough for other patients.
I fully agree. It's not the same situation for everybody in Europe.
Sure.
But you are lucky, and thank you, Pierre. Take care of you and all of the family.
It was my pleasure. Was I clear enough?
You were very clear. Thank you very much, Pierre. Merci beaucoup. So Basil, Professor Basil van Engelen, I think you're next in line. So please, the floor is yours.
Thank you. Can you see my slides?
Mm-hmm.
Okay. Good afternoon, everybody. I am the second or third speakers, and I will address more the clinical side of a trial called Optimistic, which was about cognitive behavioral therapy as a personalized intervention in myotonic dystrophy type 1. heterogeneity as a chance. I will explain this during my talk. Late Peter Harper, a geneticist, said that myotonic dystrophy type 1 is probably the most heterogeneous disease around. And although there is only one genetic cause on chromosome 19, the repeat is different in different organs, different persons. And at the patient level, although there are some similar annoying symptoms, as you heard from Pierre, there can be a big difference in the severity of the affected organs in every patient with myotonic dystrophy type 1. And the major effects are nearly all over the body: cognitive, the eye, endocrine, respiratory, skin, immune system, cardiovascular, gastrointestinal, etc. And there is, as Pierre said, no cure. There's some symptomatic treatment. And there is a difference between males and females when it comes to testosterone or to pregnancy-related complications. But as Guillaume Basset showed, there's also a difference in symptoms between males and females, a heterogeneity between females and males. And females suffer more from dysphagia, somnolence, cataract, gastrointestinal symptoms, syncope, etc. Whereas males suffer more from mechanical ventilation, myotonia, and respiratory insufficiency. So a big difference between males and females when it comes to the severity of these affected organs. And as you know, there's also a heterogeneity when it comes to age of onset. So the most severe type is the congenital type, below a child, then the juvenile type, the adult or classic type, and the mild type, which is here, in this case, the grandmother. So there is age-related heterogeneity in this disease. And that is related, as you know, with the amount of repeats between 40 and 80, mild type, repeat lengths between 100 and 1,000, the adult, between 500 and 2,000, the childhood, and the congenital between 1,000 and 5,000 repeats. And here comes, I think, the personalized approach. Because of this heterogeneity, we should treat patients differently. There's not one size fits all. If we give every person here the same block, they cannot watch the hockey game. And what we should do is we should personalize to be able for the different persons to see the match, as you can see here. So if you want to treat people equally, you have to do it in different ways, and not the same to everybody. And somebody who was the founder of the capability approach was Amartya Sen, a Nobel Prize laureate. And he said, it is about realizing capabilities, the real opportunities people have throughout their life to be and to do things they have reasons to value. So start with the end in mind, and what do the people need to realize their capabilities? And Optimistic is a large European trial that was exactly starting from this viewpoint. And we published it 3 years ago in Lancet Neurology, and I will only highlight a few things. And it was really a kind of a personalized approach, because we asked the patients, what is the problem in your life, and what do you want to work on? And as Pierre said, excessive daytime sleepiness, quick fatigue, and muscle weakness were the problems he was suffering from, or annoying symptoms, as he said. And they are also in one of the main symptoms we found in other patients. And in Pierre's case, we would work with CBT, cognitive behavioral therapy, exactly on these 3 points. And as you know, CBT is given by a psychologist during 10 months in Optimistic, 10 to 14 sessions. And it was focusing on these items I just mentioned: reduced initiative, physical inactivity, optimizing social interaction, regulating sleep, coping with pain, and also with fatigue. So optimistic was addressing multiple dimensions, not just one, sleep as well as fatigue, as muscle weakness, in a multi-system disease. So there is not a linear a way of thinking, a multi-dimensional approach to a multi-system disease. And in that way, optimistic was just like a drug trial, but different. It was more holistic. It was systems approach and not a molecular, let's say, starting point. But as you will see and hear from Peter Baumann-Thun, we will end up molecular. And it was based on zooming out instead of zooming in, based on a human model of what are the determinants of quality of life. It was treating a patient and a person, individualized, what matters to you and what do you want to work on. The main goal was to promote health, and it was more like precision care, as you can say. So, and I think the patient, they rather thought it was a good approach because there was a high retention in this trial, even in the patients that did not get the intervention, but in the control group. And as you can see, most patients thought that it was very good to have the experience of this optimistic trial, even in the non-intervention group. And this intervention group was 128 people, whereas the standard care group was 127. And even these patients, they were, let's say, not unhappy to be part of this optimistic enterprise. The results which were published in Lancet Neurology is that the intervention group, they improved in the DM1 active C. I will show you later on what it is about. And as you can see, the usual care group, they worsened. And don't forget, this is a progressive disease, as you know. So in 10 months' time, the usual care group did not improve. They reduced in their capacity, whereas the intervention group improved. And we can see that it was after 10 months, there was a significant difference in the DM1 active. And what is the DM1 active? The DM1 active is a questionnaire where people have to sign what is impossible to perform, able to perform, or able to perform without difficulty. And then it was about eating soup until running and everything in between. So it was increasingly more difficult to go from 1 to 25. And on this scale, the patient significantly improved. But also another test was a 6-minute walking test. That is, what is the distance a patient or a person can walk in 6 minutes? And as you can see, again, this is a progressive disease. So the usual care group, they decreased in their distance, whereas the intervention group improved. And that was significant also in 10 months. But so the positive effect of optimistic is, it was an optimistic, a positive name, but what we saw in the intervention group, that the social participation, exercise capacity, the fatigue, I did not show data, but it is in the paper, and also the objective physical activity measured by accelerometers on the leg, they all improved. And so I think we met the major optimistic aims of creating a European infrastructure for DM1 trials. Alain was also alluding to it, that in Europe, the organization around DM1 can need a little bit more work. And I think we started a kind of a collaboration, at least between 4 centers in different countries. We validated some outcome measures in a time frame comparable to drug trials. One of them is the DM1 active. And we improved health status in DM1 patients by applying such a CPT approach. And so I showed this, the improvement in 6-minute walk test and DM1 active C. But there is a but. And it was not only a trial that has a result in itself, but it can also serve as a platform for drug discovery. Because the question is, are there drugs that can imitate the positive CPT effect? Because some people that got CPT with DM1, they really improved their quality of life. And then we need to identify biomarkers associated with improvement. So although the starting point of optimistic was the human person, we end up with more a molecular approach. And we did not start from it from the beginning. And as you can see, what you can see here is the 6-minute walk at baseline and after 10 months. And when the baseline was lower compared after 6 months or 10 months, then the patients were on the left side and they improved. As you can see, every dot is one patient. Most patients are above the line. That means that they improved. But there were also quite a few that did not improve, that even worsened. So this is the heterogeneity, not in the disease, but in the response to intervention. And the same we have with the DM1 active. So most of the patients improved, they were above the line, they were better after 10 months compared to the baseline, but there is still a heterogeneity. And this is not a bad thing. It can even gain some insight. So we think that the optimistic trial can be a platform for drug discovery, identifying biomarkers associated with a successful intervention. So we did CPT, we divided the group in the non-responders and the responders, the not successful and successful ones. And we are now looking which biomarkers are associated with improvement, and can we find drugs that can imitate this improvement. So this is in fact what we are doing. This is kind of a step up for the talk of Peter Bram. So the heterogeneity is not a disturbance, but can give some information that CPT can be a potential platform for drug discovery. So we start with CPT plus or minus exercise, because half of the 128 people that get CPT, half of them had, in addition to the CPT, also exercise. And then we found overall benefits in a significant subgroup, but also some people that did not improve. And then we are looking, what's the difference between the ones that improved compared to the ones that did not improve, and looking for underlying mechanisms in search for novel drug targets. And it has been done by a large group in different countries, as you can see, from Nijmegen, Glasgow, Paris, Dundee, München, Newcastle, again München, and Aberdeen. So I want to thank all these people that contributed, but especially I would like to thank the patients that were involved in this trial. And based on that, I want to move from part 2 about optimistic and the stepping stone of optimistic to part 3, which is about recognition. But I first want to give the floor to Antonio back.
Thank you very much. Very clear. Now, Peter Bram, I think it's your turn. Please, the floor is yours.
Thank you. And thank you very much also for the invitation. So before I zoom in on the molecular heterogeneity that was observed in the optimistic trial, I would once more zoom in on the clinical heterogeneity. And I'm going to show you a few graphs on the 27 different outcome measures that were analyzed in the optimistic trial. And this is a correlogram, as we call it, that correlates all these outcome measures with each other. You should interpret this as the bigger the circle and the darker the color, the more significant the correlations, or the more consistent these outcome measures are with each other. And the color is not so important, so blue or red is usually because some scales are higher with improvement and some other scales are lower with improvement. When you focus on this first row here, you can see how much the primary outcome measure, the DM1 active C, actually captures also the other possible disease clinical phenotypes. And there is at baseline quite a good correlation between the DM1 active C and measures for activity, such as the 6-minute walk test and the physical activity recorded by wearables. The fatigue measures correlate very well with each other, but are somewhat less captured by the DM1 active C. And there are even outcome measures that are relevant for patients, like the apathy and perceived social support, that are not well reflected by the DM1 active C. But overall, you see that the correlations in this diagram are only moderate or even absent and small, suggesting that again, that the patient population is quite different on how they score on these different outcome measures. When you look at it in a more patient-centered view, so here on the top is a cluster diagram of all the patients, 255 patients that participated in the trial. You can see here a group of outcome measures that record general capacity, such as the 6-minute walk test and the D1 active C. And you can actually see a gradient here for patients that are scoring worse on these scales, so are more severely affected, and participants in the trial that are relatively scoring relatively well, so are less severely affected by the disease at the time of inclusion in the trial. But the remarkable patterns that you see here below, I would like to draw your attention to. So within this group of quite severely affected patients, there is still a subgroup here at the bottom that has quite positive scores on, I must remove this, oops. Move this to the side. Okay, I'll do it like this. So here is a group of patients that scores relatively well on fatigue measures, despite their overall quite severe condition. And similarly, here is a subgroup of patients that scores quite well on the perceived social support and apathy. So again, showing the heterogeneity in clinical phenotypes. As Basile mentioned to you already earlier, there is an additional heterogeneity, and that additional heterogeneity may be even larger. That is the heterogeneity in response to cognitive behavioral therapy. Whereas some patients increase on the DM1 active C scale, so get better after cognitive behavioral therapy. There is also patients that improve on the 6-minute walk test, but they are not necessarily the same patients, because when you calculate the correlation between the difference from 10 months to baseline on the DM1 active C outcome measure, there is hardly any correlation with the difference in the 6-minute walk test. And similarly, that's also true for fatigue. So there is a certain subgroup of patients that respond well and really are getting less severe after after the cognitive behavioral therapy, but that's not true for all the patients. So this adds a level of heterogeneity, and as Basile explained also to you, we would like to learn from that, and also to think about more personalized interventions that may arise from these diagrams. And that's what we try to do in the follow-up project on Optimistic called Recognition, for recognition and validation of druggable targets from the response to cognitive behavioral therapy in myotonic dystrophy type 1 patients from integrated omic networks. And the main objective of Recognition is to reverse engineer a druggable pathway from the desired behavioral response, so from the desired effect of the CBT treatment. And we do that by identifying molecular signatures, both RNA and protein in the blood, that are associated with this positive response to therapy, and subsequently the identification of drug targets from these molecular signatures, and subsequent selection of drugs for repurposing purposes. So usually looking for FDA and EMA approved drugs that may also have a clinical benefit on the DM1 patients. We subsequently try to validate those targets in mouse models, cultured myoblasts, and cultured neurons from myotonic dystrophy patients, and test them also the drugs in these mice and cell models. So the results that I'm going to show you on the molecular profiling focus on a subset of patients, 27 patients for which we recorded RNA-seq profiles before and after the intervention, so at the 10-month time point. Also on the way are serum proteomics profiling for all of these patients. As Basile already showed to you, we are interested in molecular signatures that differentiate the patients who respond to the cognitive behavioral therapy intervention and those who do not respond. When you record the changes in mRNA expression profiling, you can also cluster the patients according to this change. And here, in particular, is a subgroup of patients that respond on the molecular level quite strongly to the effect of the intervention. And it was quite notable that these patients also are often improving on the capacity scores, such as the DM1 active C. We further made use of this, but I would like to highlight another very interesting aspect of this study, and that is that we recorded distinct molecular profiles also for distinct clinical phenotypes. So not the same set, so a different set of genes is actually representing an improvement on general capacity measures. That set of genes is not the same, but it's a distinct set of genes that actually associates with a positive response on fatigue measures and quality of life. And there is yet another group of genes that respond more to physical and associate more to the improved physical activities of these patients. So it's not only the clinical heterogeneity, but we see also heterogeneity in the molecular profiles that are associated with these different responses to therapy on the different outcome measures. To make it a little bit simpler, we now turn into a graph where we have an overall measure of response to the therapy and a gene expression here. So in this diagram, we just divided responders and non-responders based on an average improvement on all of the outcome measures, and then record the differences in gene expression. And this is just a gene for which you see that in the group of non-responders, the expression usually goes up, so it's a little bit above 0. And in the group of responders, it generally goes down. And we found a number of these genes, and we found a very remarkable pattern again. So here in this diagram, every dot is a gene, and on the axis is the association of gene expression with the severity, and we took the CTG repeat number as a kind of proxy for the severity of the disease here. So here are on the right are genes that go up with increased disease severity, so are higher expressed in the more severely affected patients, and the genes here on the left are generally lower expressed in the patients with higher disease severity. What now is the remarkable thing about this pattern is that when you look also at the genes that are associated with response to the cognitive behavioral therapy, that you see a very clear anti-correlation, in particular for the genes that are significant for both effects. So in other words, genes that go up in expression with increased severity go down again after a successful CBT intervention. And we think that those 105 genes are an important signature because they are really the molecular reflection in the blood of a successful therapy. And that's where we would like to focus on in our subsequent drug repurposing strategies. So our next steps are to validate molecular targets from these blood profiles in relevant cells and tissue, and to select and validate the drug repurposing candidates then, because these drug repurposing candidates may actually consolidate, reinforce, or even replace cognitive behavioral therapy, because not every patient will be receiving cognitive behavioral therapy in the future, and it may not even apply to populations like the younger pediatric population. The other next steps that I foresee, together with the whole team, of course, is that we model heterogeneity in natural disease progression to understand better the individual and to understand, but also to predict the individual patterns in the disease, because that would allow us to select the right intervention for a person given the molecular and clinical profiles that we have recorded and personalized treatment goals that are set together with the patients. And in the end, we would like to test this in an innovative clinical trial protocol, which I sketch in this one but last slide. So whereas in the classical clinical trial design, including the trial of the optimistic trial itself, we differentiate between a control arm and an intervention arm. And you notice that the starting points, T1, of all these patients, indicated by the different colors, are different. But also the expected response, if you may say, in the control arm, you don't do anything, right? So some show a more natural degrees disease progression, some may even improve over this time period. And when you then look at the difference between the intervention arm and the control arm, you look at the overall difference, and this may be just hidden in the large heterogeneity at baseline and the large heterogeneity that there is in the extent to which the disease progresses over the time of the trial period. What we propose, on the contrary, is to first model the predicted disease progression for individual patients. Based on that, select a subgroup that is suited for the intervention based on the fact that they are predicted to decline, plus they have actually set some personalized intervention goals that they are likely to improve on. And then after the trial period, and whether that is a lifestyle intervention or a drug intervention, doesn't matter so much, we actually compare with the solid lines, the actual observed disease burden to the predicted disease burden, and actually record this difference and see that as a successful outcome of the trial if every patient actually improves compared to their own personal baseline. That's what I would like to say, and I would like to acknowledge most of all PhD student Daniel van As, who does a PhD together with Basile van Engelen and myself, and postdoc Remco van Kruften in the group. Of course, also the Optimistic Consortium and the Recognition Consortium, and the funding that we received from the eRare JTC 2000 grant to the Recognition Consortium. And more information can be seen here and read on the website, on the Optimistic website. And I would like to thank you for the invitation and the participation and listening today.
Thank you, Peter Bram. It's very interesting and challenging presentation, and great expectations, as one can say, are on your shoulders now. So, Gabriele, I'm going to unmute Gabriele Siciliano, one of our attendees, and then I will mute everybody, basically, because he's got a question. Sorry, he's here. Okay, Gabriele, go ahead and unmute yourself, please, and voice your question.
Can you hear me?
Yes.
Okay, thank you very much for those contributions that underline the huge clinical variability of this disease. And my question is to both Peter and Basile, obviously. What do you think, at which extent could be useful and advantageous to try to trace a sort of hierarchy in the several numerous pathogenic or also those clinical outcome measures that can be could be useful to harmonize and to maybe detect which tree could be the target of a given therapy. I mean, if we have a huge number of variables in trying to understand which is or which are the relative interactions between them in terms of pathogenic significance, I think that it could be useful to try to trace the lines that connect together in a hierarchical model, which are the primary and which are the secondary events that can be addressed by a given treatment, and maybe by connecting them to have more chance to address a significant target of treatment.
I give the first reaction, Peter Bram.
Should I first react? Well, I think part of the answer is actually in Pierre's interview. He actually made a hierarchy for himself, right? The three most annoying syndromes. And I think what Basile may comment on this more is that it may be a decision that you want to take together with the patient, which symptoms are more are more important to address with a possible intervention, and therefore also which outcome measures are then most relevant to record for that particular patient.
Yes, I agree. And Gabriele, what we did in Optimistic is by machine learning trying to find the determinants of the quality of life, and the amount of data per patient and the amount of patients was not enough to come up with a strong model. And hopefully, when we now continue in an Optimistic 2.0 and are able to reassess some, if not all of the patients, it might be that we have enough data points to come up with a kind of hierarchical model of determinants of quality of life or hierarchy, what is most important for the general patient with myotonic dystrophy. Is that what you mean?
Yeah.
Gabriel?
Thank you. Yeah. That exactly. Thank you.
So at the moment, we don't have questions on the site. And usually I step in on those occasions to give some time for people to lose their inhibitions. Otherwise, I will poke them in a moment. So one thing that was surprising for me in Peter Bram's intervention is that it seems that the clustering around motor capacity is not the same as the one around fatigue and quality of life. And for me, that is a bit unexpected, and because I would expect the motor capacity and the fatigue, for instance, to be closely together. And that's apparently not the case. As I know that you've done some actigraphy in these patients as well, do you have any correlation with actigraphy to show exactly that difference as well, or not?
I think Basile is really better to explain this part of the...
Yeah, Antonio, we did actography, and I'm not sure if I am able to answer your question now with the present data I have in my head. But what we showed is that the patients that improved in their health status, that were less fatigued after the interventions, were also more active. And that is something which we encounter also in other trials when we address fatigue by CPT. So we even showed that on the MR of the muscle, the less fatigued patients had bigger muscles compared to the patients that did not improve. So on the group level, there was a correlation between improvement generally being less fatigued and having a better 6-minute walk test and having a better, let's say, a higher ectometer data, and it's exactly what we also would like to achieve, that the patients, instead of being apathic, are more active in daily life. And the ectometer data showed that that the patients were in fact being more active on a physical level.
Thank you. That's very interesting. Hans-Loch Müller. Oh, sorry, Peter.
Yeah, another aspect of the the answer to this question may be that the questionnaires to record fatigue are also more focusing on perceived fatigue rather than actual fatigue. So even patients, I think, who are very active can still perceive the fatigue in a different way than patients who are not so active.
Yes, but there's no, it's like pain, you don't have a fatiguometer that you can use.
Exactly.
So yeah, you have to rely on what people tell you, so on perceived fatigue. Yeah, I understand that. So Hans-Loch Müller, you're welcome to unmute yourself and voice your question. Welcome.
Hi, Antonio. Thanks
Hi.
for unmuting, and thanks for the great webinar. I have a question for Basile mainly. After Optimistic was finished, I guess there wasn't a sort of funding generally available to follow up on all of the patients for longer, but you may have be able to continue seeing the Nijmegen patients. What's your impression? Did they continue to do CBT and exercise, and did they continue to have benefit, and would be there an option to draw more blood samples for Peter Brum's investigations?
Yes, thank you, Hans. The answer to the last question is yes, because we are now in the process of negotiating a Optimistic 2.0, and we have a large chance to get funding for reassessing the patients in the 4 different countries. So we are in the process of setting that up. And so we will reassess all these patients, if possible, clinically. We also think of giving an intervention and then reassess them again. So with also looking at biomarkers, so we will have answers to your question in a few years. And we purposely did not treat the patients in Nijmegen different compared to other cities. So they fall back in the regular care. And we also in Nijmegen and Holland, we are not able to give CPT on a regular basis. And that is also one of the reasons that we now want to make and to test a light version, an online version, an app version, to be able to give the CPT also in other countries. Because that was a little bit my frustration, that when you find a drug which has an effect, then the industry is helping you to disseminate it all over the world. Whereas in such a lifestyle intervention, we have to do it ourselves. And I'm very happy that in Australia and far away, there are people that are able to apply it to this disease. But we should come up, I think, with a lighter version, a more simple, applicable version. And in addition, we will then look at the different biomarkers to be able to share with Peter Bram the ideas about hierarchical models, but also finding druggable targets.
Thanks, that's excellent news.
Excellent. The other thing that I would like to ask is about apathy. So was apathy in the fatigue and quality of life clusters, or was it not assessed formally, or it didn't cluster as the other variables? I don't know.
Yeah, thank you for your question. Apathy was separately assessed, but the apathy evaluation scale in every patient and on the different type points. And it was assessed by the patient as well as by the significant other. So we have these data, and thank you for your question. We'll dig in a little bit more. And Peter Bram, you can probably show this graph where the AIS is the apathy evaluation scale, is one of the several. I'm not. Yeah.
Perhaps we can just so that the manuscript is on medRxiv, so we can also send the link around so that you can judge for yourselves. In general, the apathy didn't correlate very well with any other outcome measure.
And do you have a cross correlation with actigraphy as well? I'm asking too much, I know.
We can check all these data. We have it, and but I don't know by heart.
Okay. Just curious. It's a fascinating team, and
another point is also to consider that in adjunction to apathy, there could be also a disease unawareness, which not always is a problem that the patient can realize, and this could be a further element that can modelize the fatigue perception in these cases.
Yeah, Gabriele, I totally agree. And this is also a general problem when it comes to questionnaires, because I can imagine that patients with myotonic dystrophy are inclined to set their set point a little bit lower, and that the real, let's say, severity of the disease is probably higher, but that people are a little bit, let's say, more apathic or more unaware of what is really the problem. And so that was one of the reasons that we also used actography and also the AIS of the partner or significant other to cross compare what the patients are saying from themselves and what the environment and the computer is telling us.
Yeah, correct. Yeah, thank you.
Very interesting. Any more questions? Apparently not for the moment. We are quite in time, so I don't want to be the only guy putting questions, so I'm going to pick someone from the list. So Mário Gomes Pereira. So
I knew it would come to me.
Join the Portuguese team here, and
I knew it would come to me.
well, yeah. You're the guy of DM1 and brains, so I'm sure you're interested in these things. So
yeah, but actually, I had a different question because, by the way, hello Basil, hello Peter, thanks for the great talks, and I had a more basic question regarding the mechanisms back to the instability, and I might have missed something because it was a bit madness during your talk. There was somebody drilling a hole in my office at the same time. But anyway, so I wanted to know, I suppose you have done repeat instability in your first study, and to check whether or not the fast responders, for instance, have a lower rate of progression of repeat instability in their somatic tissues. Was that done? Is that something that would be useful, or is it something you consider in comparison to the low responders that, for instance, could have a fast dynamics of the repeat, and therefore the disease would progress faster, and so they would not be responding as well?
Mario, you are exactly asking the question I was also posing to Darren Monkton.
All right,
because Darren is the guy who was involved in the genetics, And he looked also at the progenitor allele size, that is the repeat size, presumed size at birth. And I asked him this question: if within 10 months we could expect any somatic instability or somatic change. And so until now, he thought that it was not worthwhile. But now, 5 years after the trial, it might be worth looking at how the patient changed over time, and if we can see a correlation between the somatic instability and the severity of the disease in 5 years' time. So I understand your question, and I was also thinking in 10 months there might be some difference, but based on money and let's say strength of the hypothesis, we did not choose to investigate this, but this is one of the main points on my wish list.
If I may add to this, Mario, so we looked at actually the associations between gene expression and CTG repeat size, and gene expression and the EPAL, so the expected allele size at birth, and we saw very similar associations there. So we didn't have, from the molecular point of view, an idea that there would be a large effect here. But to formally test this, I think Basil's call on doing this analysis again after 4 or 5 years is really good.
Mario, because it would be great. Mario, it would be great, and when we are able to fix the somatic instability at the EPAL level, and that there is no increase in the repeat during life, and find or a drug or lifestyle intervention or a combination in this complex multi-system disease, I think that would be great. And so if you have ideas about how we can test or improve or stimulate it, please let me know, because I think this is one of them. It could be one of a major contribution to the field when there are, let's say, ideas or drugs that can stabilize this somatic instability.
I think many people are looking for them, but it's not easy.
And what about metformin? What do you think? Might metformin, which has been proven by your group, by Guillaume Basset, that the muscle force is improving in myotonic dystrophy, might that do something not only muscle force, but by let's say having an influence on the repeat in the muscle?
Well, who knows? I cannot answer your question. I don't know. I don't know. It's easy to test, I suppose, but it's something it's an hypothesis. I have no element to give you an answer. I don't know. That could be a possibility, of course, but I don't know at the moment.
You have the mice, and you show the effect of metformin in patients. So why don't you take a mice, give them an exercise program and metformin, and then you look in the muscle if the repeat is changing?
We'll think about it in the lab. That's a good idea.
Okay, we can collaborate on it.
So I think this is the perfect end to the webinar. Don't you agree? We end with a proposal of cooperations and work. So I think that's the best thing we could come up with. I wish to thank Alain Jay, Pierre Petit, Peter Bram, and Basil van Engelen for their participation, and everybody that attended. And I think that it was a very lively, interesting discussion, and that we all learned something today, and that the data that you presented was really interesting and exciting, and it even triggered almost a new line of work. So what can we ask for more? No, we can't. Okay, hope to see you soon in another webinar or somewhere, and keep safe, please. Bye-bye. Bye.
Bye.
Bye-bye.
Thank you.
Thank you.